we've sort of introduced this word aromatic, and we're using it really to mean any compound that contains a benzene ring. It actually has a much more technical definition than that, which would embrace other compounds as well, but because we don't come across any of those other ones at A level, we're just going to go with that. So as far as we're concerned, aromatic means that it contains a benzene ring. So we can describe any compound as aromatic if it contains a benzene ring, or a group that's part of a compound as aromatic if it's based on a benzene ring. So we need the other word to describe compounds which are not aromatic, and that word is aliphatic. Okay, so aliphatic is a word we haven't really used before, but it just means not aromatic. In other words, doesn't contain a benzene ring. And again, you can use it to describe a whole compound or a group within a compound. So you could say that, you know, butane is aliphatic, or you could say that a butyl group was aliphatic, because they don't contain a benzene ring. So that's fairly straightforward. There is another word, which is alicyclic. And an alicyclic compound or an alicyclic group means that it contains a ring that is not aromatic, like a cyclohexane ring or something like that. So alicyclic compounds are aliphatic. They're a subset of aliphatic compounds. So, you know, if you're a fan of Venn diagrams, you know, you have aromatic compounds or aromatic groups, and then you have aliphatic groups. And within that you have alicyclic. Okay, so it's either this or it's this, but if it's alicyclic, it is by definition also aliphatic and not aromatic. So they're not words you have to use a lot, but they do sometimes like to test you on them, so make sure you know what they mean. Okay, so here's just some quick examples to make that point. So this one contains a benzene ring, so is aromatic. These two, neither of them contains a benzene ring, so these two are both aliphatic. This one doesn't contain a ring at all, so it's aliphatic and that's it. But this one contains a ring, it's just not an aromatic ring, so this one is alicyclic. So you can describe it as either alicyclic or aliphatic, but not aromatic. When it comes to naming compounds based on a benzene ring, it actually gets slightly annoying, and it's just something you have to get used to, because it's not as logical as you might hope it would be. So for simple cases it's straightforward. So this, as we know, is benzene, and so that is ethyl benzene, and that is 1,3-diethyl benzene. So that's all straightforward because it's using the same kind of principles that you've been using all the way through the course. So if this is carbon 1, then that's carbon 3, so 1,3-diethyl benzene. But what about a compound like this? If we're going to make benzene the root of that name, then we're going to have to name this branch. And that's obviously complicated by having the OH in there. It's not impossible, you could do it, but it's actually easier to name that compound by treating the benzene ring as a branch of this compound. So if we had that compound, it would be propan-2-ol, And you can see all we've done is attached a benzene ring to carbon 1. Okay, because if that's carbon 2 with the OH, that's carbon 1, and we've got our benzene ring there. So we can name it as 2 something propantuol. Now you and I might think that the logical thing to call it would be something like benzenyl or benzyl, but unfortunately it's not as logical as that, and in fact benzyl means something else which we don't use at A level, but you don't want to confuse people, so definitely don't call it that. When the benzene ring is a branch like that, you call it a phenyl group, which is written like that. So it's 2-phenyl propantuol. Okay, so you just need to get used to that. Phenyl just means a benzene ring when it's a branch of another compound. So C6H5 is the molecular formula for a phenyl group. And you see that a lot in shorthand formulae, so it's worth getting used to. When you see C6H5, just thinking, oh yeah, that's a phenyl group, which is just a benzene ring attached to something else. So another example would be, this is a very important molecule in the plastics industry, because in the old days that was called styrene. So when you polymerize it, you get polystyrene. But the systematic name for that, again, if you made benzene the root, you'd have to call it ethenyl benzene, which you could do, but what you do normally is you make that the root of the name, which is ethene, and it's just phenyl ethene is the way you name that compound. So try and get used to that term phenyl, so that you know instantly what it means when you see the name of an aromatic compound.